Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.7, and we're going to start with question number 7 today. So there are not going to be any new concepts in this exercise, so we'll just jump straight in to question number 7. And what they've given us is the equation: the function of x is equals to 4 plus 8x minus x squared. And basically what they're saying is to convert this into the form a minus x plus b whole square and find the values of a and b. And then we have to write down the coordinates of the stationary point. So let's first solve the first part of the equation. Then we go to the stationary point. First of all, we have to change this form into the squared form. So take negative as the common. I personally like to do that. It's more easier for me. X squared minus 8x minus 4. Then what we do is break this up using the whole squared method. So negative as the common, x squared minus 8x. Now what we do is divide the coefficient of x by 2. So when we do that, we get negative 4. We put a squared on it. So negative 4 squared. And obviously, if we are, sorry, it's not negative 4, it's going to go positive 4. My bad. We do not take the symbol for now. We only take the positive value. So it's going to be positive 4 squared minus 4. And obviously, this negative 4 is being taken from here. However, what we do is, as we are adding positive 4 squared, we are going to subtract it. Minus 4 squared. Okay. Well, why is that happening? We are doing this because we have to neutralize this equation. The thing is, we just added positive 4 for now out of the air. We do not know where it came from. So we have to neutralize the equation, as by adding positive 4, we have to subtract it. So in the end, it would become equals to 0. However, our process would be done. So again, we have negative as the common. Take this up, x squared. In fact, not x squared. We take x minus 4 whole squared. Basically, what we are doing is taking the coefficient, or you can say taking the sign of the coefficient in the middle, or coefficient of x in the middle, and then taking the value which we were supposed to be squaring. So bear with me for now. I'll explain you right now why is that happening. So x minus 4 whole squared, that's still here. We do not take the negative 8x for now. It's trapped in this x minus 4 whole squared. And negative 4 minus 16. And that is equals to minus 4 minus 16 is equals to negative 20 minus x minus 4 whole squared. In fact, what is going to be is positive 20, my bad, because negative multiplied by negative multiplied by x minus 4 whole squared would be give us negative x minus 4 whole squared, and negative 4 minus 16 is negative 20. So it's negative 20 multiplied by negative is going to be positive 20. So again, what I promised is that I was going to tell you why this x squared minus 8x plus 4 squared is going to be turned into x minus 4 whole squared. Basically, we knew that a minus b whole squared is equals to a squared minus 2ab plus b squared. So if we compare this with the first equation, we know for a fact that x squared is equals to a squared. So we can say a is equals to x. Simple. Now, we also know that minus 2ab would be equals to negative 8x, because that's we can see by the comparison. So negative 8x would be equals to minus 2ab. Okay. So we already know x. So negative 2x b is equals to negative 8x. And basically what they are telling us that b is equals to negative 8x divided by negative 2x. And x would be cancelled down, which was give us b is equals to 4. So we know b is equals to 4. How and this is being further, it's like this has been confirmed by the fact that we have 4 squared in the end. We took -8 divided by 2 and then added the answer as a squared. So this when we find this b out, it is a confirmation of the fact that this 4 squared is correct. So that's basically what the 4 squared allows us to do, and that's why we added it. We added it so that we could factorize this equation to make up the a minus b whole squared equation. If you are not clear about this, please do ask me in the comments. I'll try my best to clarify your confusion. So that's the first part. We found out the whole equation in the way the question asks us to. However, we have to find out the stationary point. Well, you may remember that at some point we came through this equation, a multiplied by x minus h whole squared plus k. If we had this equation, you would directly know the stationary point or the maximum or minimum value by saying that h and k are the coordinates of the stationary point. Okay, so if we compare this with the first equation, we would get -1 x minus 4 whole squared plus 20. So we would get -4 is equals to h, sorry, negative h. We cut this down. We get 4 is equals to h and k is equals to positive 20. And that's our answer. 4 and 20, positive 4 and 20 is our answer for question number 7, part 8. And that's it. It's not too hard. Just you have to remember the concept behind it. Okay, proceeding on to part B. On the axis below, sketch the graph of y is equal to fx. Find the coordinates of the point where your graph intersects the y-axis. Okay, so basically they're only saying us to find out the graph of y is equal to fx. And we also have to show the points where the graph intersects the y-axis. So when the graph intersects the y-axis, we know that x is equals to 0 at that point, when x is equals to 0. So that's one of the main factors. Another thing I want to clarify is that, remember, in the past paper question, they have provided you with the graph. Okay. For now, they have provided you with the graph. So as you can see, the emphasis is on the positive side of the graph. Okay. The emphasis is on the positive side of the graph. There's not much negative side available. So basically what they're saying us in this type of question is not take the negative values, take the positive value. So we are going to say that when x equals to 0, we get 4 plus 0 minus 0. So we are going to get y is equals to 4. And then when x equals to 1, we would get 4 plus 8, which is 12, minus 1, which is going to be 11. When x is equals to 2, we would get 4 plus 16, which would be 20, minus 4, 4 is 16. Okay, so when x equals to 2, 4 plus 8 to the 16 is equals to 20 minus 2 to the 4. So it's going to be again 16. And I'm going to take, when x equals to 3, y is equals to 4 plus 8, 3 is 24, minus 3, 3 is 9. 4 minus 9 is equals to -5, and 8 3 is 24, minus 5 is equals to 19. So y is equals to 19. Okay, so just a rough approximation, I'm going to take 1, 2, 3 here. I'm going to take in terms of, we have the maximum value at 19. So I'm going to take in terms of 5. 1, 2, 3, and 4. When x equals to 0, y is equals to 4, so it's going to be somewhere like here. Second, make a point somewhere like here. When x equals to 1, y is equals to 11, so 1 and 11. And then when x equals to 2, y is equals to 16. My bad. Wait a second. I made it wrong. When x equals to 1, y is equals to 11. So it's going to be here. When x equals to 2, y is equals to 16. 5, 5, 10, 11. And then this is when x equals to this, when x equals to 3, y is equals to 19. 19. Okay. So that's basically what the curve is, something like this. Make it more smoother. Something like this. So this is part of the curve, showing the coordinates. And that's it. This is for question number 7, part A and B. For question number 8, we have the given that the tangent, given that the straight line y is equals to 3x plus c is a tangent to the curve y is equals to x squared plus 9x plus x plus k in terms of c. So basically, they have given us equation of two lines. First is a curve and the other is a tangent. So first of all, what we do is substitute both of these into each other. So x squared plus 9x plus k is equal to 3x plus c. And we are going to get, why we are substituting? Because it's a tangent. That means it's intersecting at one point. And when it's intersecting at one point, we know that it's going to be the same. It's going to have the same x and y value at that point. So x squared plus 9x minus 3x plus k is equals to c. And we are going to get x squared plus 5 5x, so it's going to be 6x plus k minus c is equal to 0. Okay, now we know for a fact that b squared minus 4ac, when it's equals to 0, we are going to get two same values. Same values. And that would mean that it's a tangent to the curve. So for that, we would say that b squared minus 4ac is equals to 0. Now the thing is, what's a? A is equals to 1, b is equals to 6, and c is equals to k minus c as a whole. So we would get b squared minus 4ac is equals to 0. So 6 6 is 36 minus 4 multiplied by 1 multiplied by k minus c is equals to 0. Now we have to express k in terms of c. So 36 minus 4k plus 4c is equals to 0. Negative 4k plus 4c is equals to negative 36. You take negative 4 as the common, k minus c is equals to negative 36. Cut this down. K minus c is equals to 36 divided by 4. Divide both by 2. 2 2 is 4. 2 1s are 2. 8 is 16. 2 1s are 2. 2 9s are 18. So k minus c is equals to 9. And now we have to express k in terms of c. So we are going to get k is equals to 9 plus c. And that's our answer. That's it for question number 8. For question number 9, we have find the set of values of k for which the line y is equals to 2x minus 5 cuts the curve y is equals to x squared plus kx plus 11 at two distinct points. Again, we have discussed throughout this exercise that when we have two distinct points, we have got b squared minus 4ac, which is a discriminant. It is going to be greater than 0. Okay. First of all, first step, what we do is substitute both of these equations because they're intersecting And when they're intersecting, they are going to have the same coordinates. So 2x minus 5 is equals to x squared plus kx plus 11. So that would give us x squared plus kx minus 2x plus 11 plus 5 is equals to 16 is equals to 0. X squared plus x as the common here, k minus 2 plus 16 is equals to 0. Simplify this further, we are going to get x squared, sorry, a is equals to 1, b is equals to k minus 2, and c is equals to 16. Now they have told us that our discriminant is greater than 0, so b squared is k minus 2 whole squared minus 4 multiplied by a multiplied by 16 is going to be greater than 0. So again, open this by the identity a minus b whole squared. So a squared minus 2 multiplied by a, which is k, multiplied by b, which is 2, plus b squared, which is going to be 2 squared, which is 4, minus 16 multiplied by 4. I'm not going to use my calculator today. 6 4 is 24, 4 1s are 4, 5 6 64. So minus 64 is greater than 0. So k squared minus 2 to the 4k plus 4 minus 64 is going to be minus 60 is greater than 0. Now open this quadratic equation up. First of all, I'm going to take my LCM. 16. 5, 12 is 60. 2, 6 are 12. 2, 3 is 6. And 3, 1 is 3. 2 is 10, 3, 2 is 6. Yes. So k squared minus 10k plus 6k minus 60 is greater than 0. Excuse me. So you take it k as the common, k minus 10 plus 6 as the common, k minus 10 is greater than 0. So we are going to get k plus 6 and k minus 10 is greater than 0. We are going to get k is equals to 6, negative 6 and positive 10. If we construct a mini graph for our easiness, we'd get negative 6 around here and positive 10 around here. And if we construct a graph, they are asked us the values which are actually greater than 0. So when they're greater than 0, it's going to be anywhere except the values which are lesser than 0. So we are going to say that k is actually lesser than negative 6 and k is greater than positive 10. And that's our answer for question number 9. And that's it for today. I know it has been a really short lecture, but still, I don't have time for now. So that's it. Thank you.